Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue our new mini-series on working with operators. In this clip, I share some really unusual stories of some truly creative methods of inspiring operators to find their own low or no-cost solutions to common industrial bottlenecks. Empowering operators to find their own solution can be an effective alternative to the more common powering from the top approaches. I know your time is precious, so let's get started. Among the some 1,000 plants I've done troubleshooting or training in, more than a few occasions stuck in my mind as stellar exceptions to the more common business as usual. What ties these stories together is that it is operators who are the ones that mostly came up with their own solutions with minimal management direction. The solutions were wildly successful and all relatively low cost. While these stories involve winders, printing presses, and a laminating extruder, the ideas have a much wider application. This first story is about a brand new name brand winder. From long experience in the paper industry, we know that rolls in a finished set for this type of winder, a manual 2-drum, should be able to be changed out in 1 minute and 30 seconds. It was taking twice that long, even after weeks of startup and training. The service engineer was getting really frustrated, and so were the operators. So he had a brilliant idea. That was to put up a giant poster on the winder frame. After the next set, he wrote 3 minutes and 5 seconds. The lead operator asked what that number was. The service engineer said that was the time it took you guys to change the last set. The operator gives some reason that took longer than normal, and the next set was 2 minutes and 50 seconds, and the next was 2 minutes and 35. The next shift came on, and the new lead operator asked, "What are the numbers for?" The service engineer says, "Those were the set change times for the last crew." The new lead operator said, "Well, that's because Joe is a putz." The new shift changed out the next set in 2 minutes and 40 seconds, not quite beating the previous shift. Then they did a set in 2:10. By the third day, the shifts were trying to outcompete each other and had set changes down to industry standard. Better yet, once they found the ways to do this, the set change times remained decent from then on. This next story is also about 2-drum winder set change time. This paper mill was nearly ready to be shut down. The reason was that the winder was a bottleneck to speeding up the paper machine. Since winder speed could not be pushed much more, the work focused on set change time. Despite this being a union plant, everyone was allowed to try their hand at running the winder and trying various ideas. Of course, while management and engineers had a few okay ideas, they simply could not keep up with experienced operators. A bit later, I was brought in. I noticed that the ubiquitous tail attachment was done with the ubiquitous double sticky tape. It was time-consuming to do and hard on the backs, leaning over the drums while doing this manual operation. Of course, with economics being so harsh, there was no way to buy an automation upgrade. So I went to the store and bought a kid's glue stick. and got my hand to try at the idea of speeding up things. I merely wiped the glue stick along the cores and then flipped the tails over and pressed them down in a second operation. Not surprisingly, being a novice at running a winder, I didn't quite get it right, and the operator had to shut down and redo my work. Still, it was close enough to inspire the operator, who said, "Give me that stick." The operator made the idea work, not only saving 15 seconds, which is big in that operation, but saving their backs and even saving the mill for a time, because the paper machine was sped up by a few 100 feet per minute. This next story is also about a two-drum winder, but this time it was with a century-old problem with a very common defect. On my first and second trip up there, I found two solutions, but they involved either rebuilding the winder or increasing the core costs. I had no idea what to try next, even though I thought I understood the problem pretty well. On an inspiration, I decided to use the operator's intuition to come up with some new ideas. The big problem here is the risk aversion that nearly everyone in a plant has to making defects. To overcome this handicap, I offered to pay the operators to make defects to see what we could learn. The rules were very simple. The bigger the defect, the bigger the payoff. The only real restriction is that you could not break the machine. So every operator was given only one chance to try one idea. The first operator said, "Do you pay for making the defect worse on one side versus another side?" I said, "Yes. Move the defect any way you wish, and you get paid." So he cranked the skewing roll as far as it could go without the web breaking the back side. The front side was so slack that it also risked breaking down due to wrinkles entering the windup. Unfortunately, he did not budge the problem. The second operator believed that it got worse with speed. So on his first run, he ran so slow that we were at risk of attracting unwanted attention from management. On the second run, of course, he ran the winder at maximum redline speed. Well, this was interesting. He moved the problem 2 millimeters and got paid $200. I had no idea why speed mattered. Also, but of little consequence to troubleshooters, is that any reduction of defects by reducing speed would not be an economically viable solution. The joy came from a brilliantly knowledgeable and creative operator who solved the problem at no cost by breaking the long-standing rules for spreader profile setup. The details I teach in the advanced section of my Web 101 class, so we don't need to do that here. Just note that by inspiring enough operators to not fear defects so much, a single operator found a now industry-wide solution to a problem that 100 engineers working for a century could not find. This next story is for a quite ordinary printing press in a quite ordinary laminating plant. The problems they were facing were quite ordinary. Missed setup steps, less than perfect cleanups, and poor handoffs between shifts. So management encouraged and enabled the operators to write their own SOPs to produce consistency and efficiency of the quite regular tasks on their machine. The first innovation was the operators themselves made the one-page list of key best practices, instead of it being written on high from the supervisors. Each of the lead operators signed the list at the bottom. The second innovation was that management took that list and had it printed on a 10-meter tall banner and included the operators' signatures at the bottom, which were located at eye level. I have done problem solving in about 1,000 plants, and I find myself not at all fond of most recipe-based approaches to problem solving. This is based on ample experience that recipes can often become a substitute for reading and thinking. However, there are always exceptions, as this story shows. The problem was with a multi-million-dollar, newish extruder laminator. It was having more defects than its three sister machines that had slightly different machine designs. Of course, as I teach in my industrial problem-solving classes, listing differences between machines is a great way to get stuck. The corporate VP of engineering brought representatives from the 4 plants, ranging from lead operators to chief engineers. The 2 oddballs in the group were myself and a KT facilitator. What struck me from the very first minutes of the meeting was how egalitarian the meeting was. All were equal in every respect for the next 3 days. Absolutely no titles or positions were allowed in the introduction. There was no head of the table. One of the KT's facilitators' key tasks was to make sure that absolutely no one monopolized the discussion, including himself. The only person in the group of 20 besides the KT facilitator who had any special position was the local lead operator, because he had to implement the trials and experiments that we, as an equal group, proposed. We had 1 whole day to brainstorm ideas. Then we had 1 whole day where the entire $30 million machine was taken down to do as many experiments as we as a group proposed and voted on. Each person got 1 idea. Each idea was critiqued by each member, and each person got 1 anonymous vote. The results of the 3-day meeting was that we, as a group, figured out why the new machine design did not work as well. We also dispelled quite a few cultural myths along the way. What surprised me at the end during the wrap-up dinner party was that one of the participants was the corporate engineering vice president. I thought he might be there in the group, but since I had not met him, and since the meeting was so egalitarian, I was not sure until the dinner party who he actually was, until we were introduced. There are 3 starting points for a more detailed discussion of problem solving. The first is my industrial problem solving book that is a good companion to my industrial problem solving course of the same name. The second is the must-have 750-page web handling handbook written by myself, Tim Walker, and Dr. Dillman Jones. This is where we would turn for the sciences of web handling, which can guide us into more effective problem solving, but not reinventing the wheel. The caution here is that science is never complete and sometimes not correct. at least for some odd situations, as we've just seen in these stories. Last but not least is my award-winning and trademark Web 101 class that has been taken by 5,000 students just like you. Here, you will learn about web handling, winding, comment converting operations like slitting, as well as a good sprinkling of problem-solving techniques. Thank you so very much for joining me in this mini-series on working with operators. I hope you found these personal stories from the field will inspire you in new ways to think about problem solving. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.